Okay guys, in this video we are going to take a look at finding the distance from a point, so we'll call it M, with coordinates -2, -2, 0, and a line with parametric equations. So this is -3 minus 3t, and then we have 4 minus t, and we have z equals -2 plus 2t. So from the parametric equations, the first thing you can tell immediately is you can tell a point on the line. And because when time, think of t as time equals 0, you're going to get, and let's call this point P, with coordinates -3, 4, -2. So we have a point on this line, and we also have a direction vector. So how do we know what the direction vector is? Well, that would be the coefficients of t. So here we've got -3, -1, +2. That is the vector that shows direction of which way the line goes. Okay, so just imagine that you've got some point M, right? And then let me see if I can draw a line. So this is some line, right? And on the line we've got a point. We identified the point, and that point is P. Okay, and then we also have a vector that shows direction of this line, right? So this would be a vector that starts at P and just goes along the line. Okay, let's make it maybe green or something so we can see it. I don't know if you can change the color, but whatever. I think right now it's purple. Okay, so what happens? So this right here is your vector V. Okay, and if you look at, let's go ahead and join P and with M with the vector. So we'll just join it with another vector. Now look at these two vectors, V and vector PM. If you think of these two vectors actually as adjacent sides of a parallelogram, okay? So just imagine that I'm gonna continue drawing this and get like a parallelogram, right? So you should know that the area of a parallelogram is the magnitude of the cross product of PM and V. Okay, so that was one of the formulas. The area of a parallelogram is the magnitude of the cross product, where these two sides should be adjacent sides of the parallelogram, right? And also we know from geometry that the area of a parallelogram is equal to base times height, right? Well, what's base? Base is the magnitude of vector V. And what's height? Well, height would be if you drop a perpendicular from M to the line, right? So this would be a 90-degree angle right there. So this is like a 90-degree angle over here. So this is your, let's call this D, distance, right? So that's going to be right here. So it's area of a parallelogram is base times height. And so what we need to do is we need to find this D. And to find this D, we're going to find the magnitude of the cross product of PM and V and divide it by the magnitude of V. Okay, so that's our formula. Let's go ahead and implement that, right? So first, what is a PM vector? So vector PM joins point P, which coordinates -3, 4, -2, and M -2, -2, 0, right? So let's find this vector PM, its components. This does not look good. Okay, let me just fix the M. It's really hard to draw with this pen. Okay, so let's subtract the coordinates of P from coordinates of M. So we're going to get -2 subtract -3. So that's going to be +1. -2 subtract 4, that's going to be -6. And then 0 subtract -2, that would be 2. Okay, so we got that. Now we want to find the cross product of PM and V. Okay, V is -3, -1, 2. Okay, so let's find the cross product. So for the cross product, we're going to draw one long determinant, right? So we're going to draw this one big determinant. We're going to put standard unit vectors as the first row. So that would be ijk. Then PM, and then V. Okay, so how do we find the cross product? So first of all, we start with the ith component. This is where we're going to cross out the row and the column where I is, right? And we're going to get this little matrix. So we're going to multiply the diagonal elements and subtract the product of the other two. So this is going to be -12, subtract -2, which is +2, right? Then we move on to J, and remember that J always comes with a negative. So now we want to go ahead and adjust. So let me just get rid of this for a second. So let me move this guy in here. and this guy in here. And now we are crossing out the second column, right, and the first row. And then we multiplying the red elements, right, and then subtracting the purple ones. So 2 times -3. Okay, so that's the jth component. Now let's go to the kth component. So here, let me move this out of the way for a second. So here we're going to be crossing this out, right? So then this is going to be here. And this red one is going to go over here. And then now we're going to cross the last column. Okay, so that's the kth. So remember, plus, minus, plus. So here we're going to have -1, subtract -3 times -6, that's 18. So I'm going to subtract 18. Okay, so that is going to give us in component form -10. So this is going to be 2 plus 6, that's 8, but we also had a minus, so that would be -8. And then this looks like it's -19. So one thing that you should always check is go ahead and use Desmos calculator to check to see if this new vector is orthogonal to each of the individual vectors, right? So this new vector that we got with the coordinates -10, -8, and -19, we're going to multiply it by each individual vector. So first of all, let's multiply it by 1, -6, 2. -6. Okay, so we're adding them up. And then 2. Okay, so we got 0. All right. Excellent. And then now we want to also multiply this. So let me just copy paste this over here by the second vector, which is going to be -3, -1, and 2. And that's also going to give us 0. Okay, so great. So we found the cross product correctly. And now we just have to find this magnitude. Okay, so the magnitude of PM crossed with V. So remember, to find the magnitude, we just square each component, add them up, and then take the square root. So, and minuses, by the way, do not ever carry them, because once they're squared, they go away, you don't need them. Okay, so I've got 525. So the magnitude is going to be square root of that. Okay, and then you want to divide that in the formula by the magnitude of V. Well, what was V? Well, it was -3, -1, 2. So again, let me just square each component disregarding the signs. So that looks like that's going to be divided by square root of 14. So I think that that's my answer. So let's look at the exact form. So this would be square root of 525. You can bring it under the whole root. Or you could have separated it, doesn't matter. Now, it wants also distance in rounded to 2 decimal places. Not sure why it wants that, but it's not my question, so I would just ask the exact one, but whatever. So this one is going to be approximately 6.12.